Hi, hello, hi, hello. Good evening, all of you. Hi, hello, all of you. Good evening. The voice is audible to you. Hello, hello, all of you. Good evening. Hello, voice is clear. Hello, yes, voice is clear, pa. Yeah, Nikhil, inform to all. They will join. They have to join. Hello, hello, Nikhil, Shabarish, Shabarish. Yeah, good evening, Nikhil. Shabarish, good evening. Okay, shall we start? Otherwise, we have to wait 2 more minutes. Nikhil only is there. Shabri is also not. He left. I think so. Hello. Slow mode. I think network issue. It's not a slow mode. It's not a fast mode. Yeah, Benito. How are you, Benito? Good evening, Pa. Benito. Okay. Lag spikes. Who is lag spikes? Shall we start? Okay. All of you give thumb symbol like this. Yeah. Should we give thumb symbol, Pa? Okay. Okay. Everyone like that chat, Pa. Video. Like. Okay, Nikhil, they joined. No, I think not joined. Who are there? Please specify your names. Specify your names. Benito is there. Next, Nikhil is there. Next, Shabarish. Yeah, Okay. Anyhow, we will start. Okay, Nikhil, we will start. Huh? Yeah. So let us see. Or later they will join. So this is uh, electric field and charges, right? So we have to take first of all electromagnetism. This electromagnetism we can classify in the two types. This is the which electrostatics, and the next one is magnetism. So magnetism we will do later, we will discuss later. Now here we have to focus on electrostatic. So this electro is there, no? This electro we can classify in the again two types. One is that means here based on the electron. This is also based on the electron only we can classify. But here static based on the charge is at rest, we have to study about the rest charge, that is called the electrostatic. So charge is at moving condition, so that is called the electrodynamic. So dynamic charge, sorry, dynamic current, this is the static electricity, static electricity, dynamic electricity, charge at rest. So the study of the charge at rest is called the electrostatics. The study of the charge at motion is called the dynamic, electrodynamic, electrostatic. Static electricity, dynamic electricity. So this is important here. Important means, so from the base we have to know it. Right. So let us see. If I will consider the, this is the atom. Atom consists of, I think you know very well about that. Atom consists of protons, neutrons, electrons. So see these electrons, right? I think electron, the charge of the electron is minus 1.6 into 10 power minus 19 coulombs. Mass of the electron is 9.1 into 10 power minus 39. Next, right? So smallest unit of charge is, right? What is the smallest unit of charge is coulomb, 1 coulomb. So that is the symbol is E E. So this is the smallest one. And the next one is proton. Charge on proton, that is represented the 1.6 into 10 power minus 19 coulombs. Mass of the proton is 1.67 into 10 power minus 27 coulomb. So here you have to see, you have to see a charge cannot be massless. A charge cannot be massless, it should be mass. A charge repel each other where unlike charges attract each other. See, similar like charges repel, unlike charges attract. A neutral atom have equal number of electrons and protons, and you know that how the charge is become the positive charge, the charge is become the negative charge, how it is. So let us see, I gave a clear, so these points let us hear. A a neutral atom have a equal number of electrons and protons. If we remove the electrons, it will become the positively charged electron, right? If you remove the protons, sorry, not the protons, if you add the electrons, that it will become the negatively charged particle. So now let us hear, charges can be manipulated by process of like rubbing, conduction, induction, photoelectric emission, thermo 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 thermonic emission. So you notice that already I told you, right? So how rubbing, how that is that process, how it is, if if any two particles are rubbing, what happened, already I told you, right? See this? See this? Okay, now I hope it gives a clear idea, na? Right? Just it is remembering you. So let us hear. Okay, na? So this is giving the clear information, I think so. Okay, na, Nikhil? Nikhil, Mr. Nikhil, just give one thumb symbol. If you okay means give a thumb symbol. If it is now, I will go to the next slide. Okay, so let us see. This is properties of a charges. So this is the glass rod. This is silk cloth. These two are rubbing here. So glass rod consists of a, this is the atomic structure. Atomic structure inside the atom, glass rod atom. Sorry, no, it's not a glass rod. So let us see. This is the silk cloth. So it is the silk cloth, it is the glass rod. So these two are rubbing. What happened? These are the atomic structure of the silk cloth and the glass rod. So what are the molecules, atoms, electrons inside the atom? So inside the silk cloth and the glass rod. So this is the, it gives a very clear explanation. So let us say first case, before rubbing, suppose for example glass rod has, right, 8 electrons, 8 protons. This is net charge is for the glass rod is 0. Next silk cloth, 4 electrons, 4 protons, next charge is 0. If I will take a 1 electron is transferred from glass rod to silk cloth, then it lost the one electron. That means remaining here 8 electrons is there. Sorry, 7 electrons are there, 8 protons are there. Excess of the proton is 1 is there. That means it is the positive charge. Next, initially 4 electrons, 4 protons, one extra electron is added here. So that's why one extra negative charge is there. That means silk cloth become a negatively charged cloth, glass rod become a positively charged rod. So this is the way the silk cloth is become the negatively charged and the glass is a positively charged, right? So this is remaining one electron, two electron, three electron, like that. So how many electrons? First case it is transferred, second case transferred, third case transferred, like this. Okay, from this you have to know one of the property. For an isolated system, net charge of the system remains constant. This is one of the important, right? Keep in your mind. Okay, right. Now here we have to notice that when a glass rod rubbed with a silk cloth, one or more electrons transfer from one atom of a glass to silk. Thus, glass become positively charged and silk negatively charged. Okay, na? Right. I hope it gives a clear idea, right? What I was explained here. So the transfer of the charges, right? Now, yeah, see here, this is the least possible value of charge that can be transferred is the charge is electron 1.6 into 10 power minus 19 coulombs. Charge can be transferred only in integer multiple of charge on the electron. In other words, charge is quantized. Quantized is nothing but the integral multiple of the, sorry, here we have to say here, integer multiple of a charge on electron. So Q equals to plus or minus Ne. Q equals to plus or minus Ne. So here N is the integer, that is important here. Okay, na, right? Nikhil, other than Nikhil, who is there? Please give a thumb symbol. Shabaris, give a thumb symbol. And Shan, give a thumb symbol. Shan, Shan, give a thumb symbol. I have to confirm it. Very good. Yes, Nickel Benito, Sean Nelson. Okay, right. Only three members only. What about uh, Sharwan and next to Mr. Ajish? They did not join. Okay, later we'll discuss that is. So let us see how the when silk cloth is rubbing with metal rod or glass rod. So this is the way the charge is transferred. So glass rod has maximum electrons. It will transfer like this. It will become the negatively charged silk cloth. This is the positively charged glass rod. Okay, so let us see. This is, I think it gives a clear idea about that. Hello, Daniel. How are you? Yeah. Okay. Thank you, Daniel. So let us see properties of charge. Properties of charge. This is the glass rod. If I will take another positively charged rod, one more positively charged rod, these two are keep very close. These two are like charges, repulsed to each other. This is the same case positive negatively charged rod, this is also negatively charged rod, these two are this is this the diagram is represented the negatively charged side, same charges repulse, right? This is we have to notice that opposite charges are attract, like charges repulse each other, opposite charges attract each other. Now let us hear. So in this case, total charge is how much? Charge is a scalar quantity and it is followed by the additive nature. The charge can be added with their signs. So it is a conductor. This conductor consists of a Q1 minus Q2 minus plus Q3 minus plus Q4 minus Q5. So what is the total charge of the system? So Q net equals to Q net equals to Q1 minus Q2 plus Q3 plus Q4 minus Q5. This is regarding. So this is the net charge. And also they given here. So let us say one more problem like this. Q1 equals to 2C, Q2 equals to 4C, Q3 equals to 2C, Q4 equals to minus 1C, Q5 equals to minus 3C. Then what is the total charge? So we have to add. Then finally we got it. This is the answer. Okay na? So this is the way to calculate the total charge of a conductor, right? Yes, now we have to see here an isolated system contains three bodies A and B and C, which contains 2 coulomb, 3 coulomb, 1 coulomb charge on them respectively. After undergoing some process, charge on body A, B is 5C minus 2C respectively. Find the charge on body C. So let us hear. What is the answer for this? Do and say, pa. I think already we discussed, no? Hello. Yes. Got it, huh? All of you. What is the answer? Got it, huh? All of you. Yeah, very good. Nelson got. Very good. Okay, Nikhil got. Very good. Okay. Similarly, we'll go to the one more slide. Yeah, very good. Daniel plus C upper. Right, right. Okay, okay. One C. One column. Good, good. Right. Super. Next, I think now we have to give all thumb symbol upper. Yeah, I think 6 members they gave. I want to know it. Please. Yeah, right. Yeah, king is yar king appa. So king yar king. May I know who is the king. So everyone, please specify your name. Please type your name. I want to know it. Hello, hello, Nikhil and Nikhil. I can able to see. Sean, I can able to see. Benito, I can able to see. Next to Daniel, okay. Next to Shabarish, okay. So just give one thumb symbol. Oh, king is back means very good, very good. Okay, okay. Next, Ajish also joined. Right. Very good. Okay. Okay. Okay, Mr. Kishore. Right. Now, let us see one more question. Similar question. So, yeah, yeah. This is the solution of the, what is the, not a similar question, solution of the past question. Okay, now once you have to check it once. I think it gives a clear idea. Right? Okay, na? Got it, huh? Clarified, huh? Check it just briefly. Yeah, see Mr. Nikhil, not a Nikhil, Ajish. So let us see, it has two positive charges, three positive charges, one negative charge. Okay, na? So initial charges for all. So total charges of this all 3 plus 2 minus 1, 4C only, na? So after final, this is how many charges are there? 1, 2, 3, 4, 5 is there. This is minus 2. So let us see 5C minus 2C. This is x we have to consider plus x. So totally you have to equate this. These two we have to equate this because of initial charge equals to final charge. Initial charge equals to final charge. So this is 4C equals to 3 plus x. Then x equals to 1. Okay, na? Okay, na, Ajish? Okay, now, so let us hear one more. Intrinsic property of a matter, scalar quantity, and a exact force on the bodies, it is distance. So this is one of the important keep in our mind. Charge cannot exist without mass. This is important here. Charge cannot exist without mass, but mass can exist with zero net charge. This is also important. Please concentrate. So charge cannot exist without mass. So mass is zero. Definitely charge kandipa zero. If mass is zero, definitely charge kandipa zero. Okay, na? Right. Mass can exist. without zero net charge. So that's why here mass cannot zero even though charge is zero. This is important part. Sometimes they will ask a statement type questions. This is that related. Keep in your mind. Okay, next. So let us here. So here we have to notice that two types of charges: positive charge, negative charge, attractive force. And here positive charge and negative charge attractive force, and this is a positive charge and positive charge repulsive force. So let us see mass. What happened for the mass? Mass is always attractive. Mass is always attractive. It is always positive. That is important. It is a difference between the mass. Okay, this is not required. Okay, so let us see. I think applications of the Gauss law. So this is the one of the very important problem. So let us see here. Conducting concentric thin spherical shells. Already I discussed with you. Conducting concentric thin spherical shells. This is one of the cell. This is the another cell. So see here, tuck tuck na. I think here potential we don't want. Tomorrow Monday test potential don't want. So we have to calculate only electric field. So here they mentioned here E, B, C. E, B, C. Where is the A? Sorry, not E, B, C, A, B, C. Where is the A? Where is the B? Where is the C? Check it once. This is the solution. Takku takku solapa. It is right or wrong. If we have a doubt, specify here. I will give a clarity. Okay, na? So point charge, no need to calculate Benito. Benito basically point charge, no need to calculate. They will give. Don't worry about that. If point charge means, if I will take a magnitude is 1. Point charge means magnitude is 1. 1 coulomb. That is the point charge. Generally we have to take. Okay, na? Benito? Okay, next. Anybody doubt from this? So let us see. Next one, what happened? This is electric potential. It's not required in this time. Right. This is also electric potential. In this time not required. So let us see. This is the one more question. One more question. Look at this, all of you. Okay na? Okay, next I will go to the next. It is clear, huh? So let us see. This is the one of the sphere, this is the small sphere, right? Two conducting spheres S1 and S2 connected through a wire as shown in the figure, where S1 is the solid sphere and find the final charge on both S1 and S2. So this is S1 and S2 here. So when the two spheres are connected, all the charges from inner sphere will reside to the outer surface. This is important. So these two are connected, total charge will come reside on the outer surface. Because of these two are conductors, conducting spheres. Conducting spheres, charge should be outside. This is important, right? So now what happened? They both act as a single conductor. Then what about the inner sphere? The charge of the inner sphere is zero because of it is the conductor. The charge pass to the inner, from inner to outer. It will go. It will stay outer surface. Okay, na? Enapa nickel doubt? Sigma by r square can we use? Yeah, sigma by r square. How it is? Pa? Sigma naught. Sigma na epsilon naught. Nikhil, sigma na epsilon naught pa. So now let us hear. Conducting concentric spherical shells. Conducting concentric spherical shells. Epsilon, yes, that is different. This is different. Yeah, that is if you want to find out the flux, we can find out q by epsilon naught. Okay, na? Q by epsilon naught. So, but they're asking electric field. So that's why you cannot use. Okay, na? So see this question, right? So let us see three they given, I think so. Distribution of charge. Okay, now conducting concentric thin spherical shells. So this is first one. This is charge is inside S1, S2, S3. S1, S2, S3. What is the S1 charge? S2 charge, S3 charge. So let us see. Initially charge on different cells as follows. S1 is Q, S2 is minus 2Q, S3 is 3Q. Inside the inner shell S1 is minus Q charge is placed. So this is minus Q. Okay, na? Inside. Then right, therefore the induced charge on S1 is follows. That on inner surface S1 is plus. Okay, I think so. Plus 1. Outer surface S1 is minus 1. So let us see. Inner surface of S1 is follows. Right, first one is inner surface is plus Q, outer surface is minus Q. Then hence the total charge as follows, that is on inner surface is plus Q, on outer surface is minus Q plus Q, that equals to 0. So let us see, this is the outer surface, this is the inner surface. Because of, right, okay, here this is somewhat complicated. We will discuss last this type of questions. Let us see. We'll go as usual. Yeah. See this? I think this is our method. Once again, go very slowly. This it is choti infinite sheet, infinite conducting sheet, infinite conducting sheet. I think Rayan not came. I think so. Selva Shubbian. தமிழ் கொஞ்சம் கொஞ்சம் புரியுது தம்பி. அதிகமா புரியாது. அது கொஞ்சம் ஓகேண்ணா தம்பி. Sorry தம்பி, don't mistake me. I will use little bit, but okay na. So let us see. This is a conducting sheet. Conducting sheet and a charge outside. So if I will place a charge sorry, if I will place a charge here, definitely it will come outside. Both surfaces. In the side charge varum, in the side charge varum. Okay. So if I will take a sheet, suppose this is the sheet. Let us see. This is the sheet. If I will give here, no battery. This is no battery. Nothing. Charge laptop charge is completed. So that's why I kept a charging cable. Okay now. Okay. So let us see if this is the conducting sheet like I am showing to you. This is the conducting sheet. This conducting sheet, if I will place a charge here, charge is in the side, charge is in the side, charge is in the side, charge is in the side. So then what happened? So this is the charge on the surface. This is the second surface charge. Okay, na? Then what happened? It is act as a sheet, one of the sheet. It is act as a another sheet. Okay, na? So these are the two different sheets. So here we have to calculate the point electric field at this point, right side. Sorry, elect so right side, left side, middle. So left side. So this is the formula, not this. This is the formula, right? Sigma by 2 pi 2 epsilon naught plus sigma by 2 epsilon naught. That is given by the sigma by epsilon naught. Sigma by epsilon naught. So this is the charge. So here we have to notice that we have to remove the charge. This is the surface charge density. This surface charge density I remove. So we will get it Q by 2A epsilon naught. Q by 2A epsilon naught. This is for left side, right side. Then what about the middle? Middle is 0. I think you know very well about that. Middle is 0. Okay, pa? So let us see. This is the single layer. Okay, now non-conducting infinite sheet. Non-conducting infinite sheet. If it is non-conducting infinite sheet, what happen? Charge is where we have to give, it will be there only. Charge, it will be there only. Okay, na? So let us see. E equals to sigma by 2 epsilon, sorry, that is sigma by 2 epsilon naught. Already we calculated how we got this. Right. Right. Oh, Ajish Raj. Thank you, Ajish Raja, Selva, Subbayan. Okay, right. So based on this, we have to discuss one of the one of the few problems based on this. We will discuss here. Let us see. Okay, everyone like pa. Hello. Only three members only liked. Everybody like. Everybody like. Everybody like pa. Hello. Everyone like. The question is visible to you. The question is visible to you. Look at this question. Look at this question. So look at this question. So this is a metallic solid sphere is placed in it is visible to you or not? If you say it is not visible, I will zoom it. Hello, Chetan Bhagat. Chetan Bhagat, ట్యూషన్ అయిపోయిందా? చేతన్ భగత్ చేతన్ భగత్ ట్యూషన్ అయ్యిందా? So let us see the question clearly. I think it is visible to you clearly. Answer this question. What is the answer? All of you answer this question, appa. Hey, 9 members is there. Currently 9 members watching. All of you answer. Like pa. Okay, now visible pa. Daniel. Dan, now visible the question. Answer this question. No, 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 no. Kanchana is not. Uh, it is my home. From my home. My son is watching. Very good, very good. Thank you. Yeah, what is the answer? Answer this question, Appa. Daniel, Ajish, Nikhil. Answer. I want option. You have to elect the options, Appa. Put a option number A, B, C. So I think D is not there, no? D is not there. A, B, C, D. Very good, Daddy. Tuition completed. Super. Yeah, answer this question. C. I think I here one more option. I have to give you D. Right, I will give you writing. Pen. Yeah, color. So D option is there. That is fourth option. సార్ చెప్పండి మూడు అయిపోయిందా? సరే వస్తున్నా, ఒక 10 నిమిషాలు, 5 నిమిషాలు. ఓకే. Yeah, D is the right answer. Yes, because of electric field lines, once it is entering, we don't want to show inside. Inside we don't show it. Outside only we have to show it. Okay, na? That is important. Yeah, correct answer E. Hey, E illada. Ajish E laba. So this is the right answer. Okay, na? Next question. So let us see next question. So what is the answer for this? Electric dipole moment of combination shown in the figure. electric dipole moment of combination shown in the figure? What is the answer? Actually, these fields are imaginary fields, so we don't want to show inside. We have to show outside only. Okay, na, Ajish? Yeah, and one more important. So let us see. This munnadi question. This is the conductor only, na? Ajish, this is the conductor only, na? What is the E net inside? E net equals to 0. So that's why you don't want to show it. Okay, na? Next, what about the answer for this? What is the answer for? So for this, what is the answer here? This is minus 3q, one of the dipole, another dipole, right? One more dipole. Hello? Hello? చూసినానప్పా. లేదప్పా, ఇప్పుడు తినాలప్పా. ఇది అయిపోతే తింటా. సరేనా? చదువుతానప్పా, చూసానప్పా. సరేనా? నేను లైవ్లో ఉన్నానప్పా. మళ్ళీ చేస్తాను. నేను లైవ్లో చూస్తున్నాను కదా. Right? So it is what happened. This is 45. This is 45. Right? Sorry, not a 45. This is 90. So this is P1. This is P2. This is P3. So the resultant of P1 and P2 also going like this. Angle between P1 and P2 is 90 degrees. So P net between 1 and 2. So we have to write P1 square plus P2 square. Right? So because of it is cos 90 0, then here plus P3 we have to calculate. Then if you calculate this, what you will get it? Enapa? So here we have to calculate here regarding, so the electric dipole moment of combination as shown in the figure, they are asked. Right? So what is the answer, pa? Solapa answer. Everyone type answer, pa. Do and say the answer. Oh, B. Padmanabhan. Hello, Paddu. How are you, Paddu? What are you doing, Paddu? Padmanabhan. Harikesh. How are you, Harikesh? How are you, man? What are you doing, Harikesh? Okay, now So according to this, yeah, this is the right answer. Some of the students they gave an answer very good. So next, one more question. So let us here choose the correct statement. Polar molecules have a permanent electric dipole moment. CO2 molecules is a polar molecules. H2O is the non-polar molecules. The dipole field at a large distance falls off as 1 by r square. Right? Which is the correct statement, Pa? All of you answer this. Which is the correct statement? Yeah, which is the right answer? Sir, B. Hey, Harikesh, it's not a B. Check it once, Harikesh. Second, no. Which is the correct statement? They're asking. Correct statement. Refer our Master G books are there. Refer it and answer it. Yeah, Padmanabhan is there. Yes. Yes, Mr. Shabarish. And next, Daniel. Next, Sean. Benito Besley. Very good. All gave an answers right. Super. This is the right answer. Polar molecules have a permanent electric dipole moment. Permanent electric dipole moment. So let's see one more question. So let us hear one more question, Appa. What is the answer for this? Harikesh, very good. Padu left arm. Harikesh, what are you doing? Padmanabhan, what are you doing, Mr. Padu? How many marks you got, Padu? Padmanabhan, how many marks you got it here? You did not say. Okay. So what is the consider the charge contribution configuration spherical Gaussian surface as shown in the figure. When calculating the flux of the electric field over the spherical surface, the electric field will be due to. What is the answer for this part? See here you have to notice that they're asking when calculating the flux of the electric field over a spherical surface. So that's why it will including this is also over a spherical surface. That means together all together, right? All of this. This is all the charges. Okay, na? Okay. I think time is over. Uh, we'll conduct some other day. Okay, pa. Thank you. Thank you. Who are coming for this live? Yeah, I think once again, who are came here, please give a please like my live. Okay, na? Put a comment, right? Thank you all of you. Right, thank you once again. All of you like. One more. Thank you once again. I will stop. Okay, good night.